Yeah, welcome back to another video regarding this ongoing project. In the last video we discussed this waterproofing system. So as we continue from there, but in case you have not seen those videos, you have to go back to video 6 or 5 and see what you can learn from there. So we begin the raft, basement raft slab is going on now, and you can see, notice your short direction and this is your long direction. So this short direction is laid first, understand, and the steel is size of the steel. We are using 150 spacing, 16 mm. That is equivalent to 7 numbers per meter both ways. All right. The cover of steel from the main reinforcement, that is the short direction, must not be less than 75 mm, and the side 5 mm. Put this into consideration. You can see the detailed section, the main reinforcement and distribution, which is the top, 7y16 per meter. Okay, you notice additional, there's the basement raft foundation. Continue. You can notice additional steel. These additional steels are all the internal columns, rectangular columns, 3.5 by 4 meter, additional size 16 mm both ways at 130 mm spacing. For additional, the detail you can see is all at the columns, all internal columns. This basement drainage system, all right, and see, notice the main pipe, I think 160 mm, and the minor pipe should be 110 mm. This is the minor pipe as per drawing, and this is the main pipe. This pipe must be pressure pipe, 4 mm least. Okay, this is the top steel reinforcement of the raft slab. Notice your short direction and your long direction, and this short direction should be placed on top of the long direction, meaning that the long direction at the top, remember at the bottom the short direction comes first, but at the top it reverses. Okay, the long direction comes first before the short direction. As you can see, this here, this is the long direction, while this is the short direction. Coming to bottom, this is the short direction and this is the long direction. So at the bottom, this was laid first before the long direction. At the top, the long direction was laid first before the shorter direction. And make sure you're lapping, you're still lapping not less than 1 meter. Top stay cover must be 50 mm, right? Okay, here after the top reinforcement, we now laid the starter bars. You can see column starter bars, shear wall starter bars, lift starter bars. We also have fire water tank starter bars, pump rooms, also made of shear walls, and the ramp starter bars. Where you can see the lift. Try to show you the lift foundation. You understand? Look somehow complex but simple. You just have to start with the bottom. Like this is the bottom of the foundation. That is the steel here. Laid first this bottom, which we allow to come up to meet with the RAFT slab top reinforcement. It has to anchor at the top. This happens both ways. Both ways are the main reinforcement of the foundation. Then this is the top. At the depth of 60 or 600. This 600 mm, the depth of the lift foundation. So we allow all these starter bars for the lift wall. Lift wall, we used vertical 14 mm, horizontal 12 mm, all at 150 mm. Here we lay water stop bar. You can see, make sure this water stop bar should be laid before the slab concrete. Don't make the mistake of leaving it out after the slab. We are most likely think about these are the water tank, fire water. We also have it in shear wall. You can see running all the perimeter of the wall. This is laid at to control the permeability of water at construction joint. So here is where you should have construction joint. You lay it there. Also, we laid it, you can see it now, at the lift. These are the ramp ramp shear walls. This is a ramp. Our ramp is not that suspended. It is only suspended at the water tank and pump room. Here is the somewhere here is the pump room, and here is the water tank. After like I think like 7 meters after this water tank and pump room, we make backfill. We rest it on the backfill. It's not suspended all the way. Vertical members 14 mm at 150 to 175 mm. Horizontal 12 mm, 150 to 175 mm. Very important are the ramp footing. This trench is meant to collect rainwater from the ramp. So it's normally like there are two of this pipe. One is somewhere here. Placed at slope at least 2 to 3 centimeters per meter. So this is the sump pit. Depth 1.2, width 1.2, 1.2 by 1.2, and the depth 1.2 also. You can see the detailing. How it goes, the bottom always come to the top still. All same, we use the 16 mm. I will use 12, but since our raft is 16 mm, so we have to adopt the same size here. Notice the main pipe from both sides of the building. So the length of this building is 95 meters. So the sump pit is a kind of at the middle. So the two pipes running from each end, collecting water, drain water. All right, here is the casting day. Notice we finished the floor the same day it was casted. This is the power float going on. This was done before concrete set properly, and at the end of the day there will be no single crack. I mean, this casting lasted 24 hours. Yes. Here is the finished floor. You can notice the 40 by 40 centimeter gully drain was sloped. The surface was sloped into these gully drains. The main pipe and the minor pipe all surface sloped into the drain. Every 100 cubic meter of concrete we collected 6 cubes, and you can see the strength at 7 days, average strength at 7 days, and average strength at 28 days of age. Right now the project is going on. Please subscribe to join, subscribe to have updates of this project. Right now we are working on the shear walls, columns at basement level. Thank you.